Friends, morning to all of you. Today we are going to see uh, just for about 1 hour a session on uh, using the software called pspp, and then I'm going to show only two statistical tests that we would demonstrate, and then yeah, it's very heavy and then extremely tiresome for me for various reasons because of continuous online sessions. Talking non-stop for hours is causing a lot of weariness, and then unfortunately a colleague of mine passed away and yesterday, and then another gentleman known to me has passed away, so that is very heavy on me actually. So uh, not able to come to grips with the reality because of that. So today I will not have much elaborate session, so just only one session we will have. Yes, we will try to see the software particularly because this entire week we are only going to demonstrate that software, and then few more statistical tests we will learn how to do it, and then I think from tomorrow again I'll come back fresh with a lot of additional inputs. So with that preview we will start the, and then these are also two pre-recorded videos, not for more than 50 minutes. So I think by 1 o'clock most probably we will conclude today, so we will not go until 2 o'clock. So I hope my voice is loud and clear to every one of you. So if it is so clear, we can straight away move forward. Somebody can put yes or no. Good morning to all of you. If my voice is audible, I think we can move forward. Just let me know whether my voice is audible. So I think I will not wait for long. So straight away, I think now the voice is audible and then video streaming is also doing well. So straight away, I will start with the session. So our topics for today, we are going to see two parts of analysis of data, part 4 and part 5. So we will see in part 4 and part 5 demonstration of the software as well as application of some statistics which otherwise you would have learnt in your previous semesters. So let's move forward. We will start with the first one.
Dear students, in this video I am going to demonstrate how we can conduct one sample tests, and of course we'll also do with two sample tests. So in the previous class I had shown you how we can maneuver through your data using PSPP and then look through your variable view, data view, and then also we had sufficiently spent time on cleaning the data view because raw data needs to be perfectly clean so that you can move forward with your data analysis. We had also seen how to analyze and what are all the menus that are available in this software. And then we had seen file menu, edit menu, view, data, transform. We've tried one transform command also called record into same variable. And then we've also seen through descriptive statistics, particularly frequencies for data cleaning, because if you go through frequencies, you would know how your individual variables are distributed or responded by your sample units. And now we're going to start with um, compare means, particularly one sample t-test, one sample tests, and then we'll get back to the next one called cross tabs in descriptive statistics. So let's start with compare means. So what we'll do, let's move to compare means and then click means. This is all about one sample. So if you want to know the mean scores of all your continuous variables like age, number of children, monthly income, experience, number of subordinates, and number of promotions availed, So treat them as dependent variables in the dialog box, and then you want to compute the mean scores of respondents on all the select continuous variables according to their gender. So we'll move gender into independent list. Now once we do that and then click OK, now you would see now your output would look like this. Now this is a case process. I don't need this. So slowly I'll move down to see this table. Now here you can see what is the average age of males and what is the average of females. So I can see like this, what is the average number of children for males and females, monthly income, sorry, annual income, it has to be corrected, income for males and female, experience, average experience of males and females, number of subordinates reporting to males and females, number of promotions for males and females. So this is one table you can generate and then take it straight into your final results. Now this is the way you can compare means, but if you want to know the means difference and the significance of mean differences, what you should do is get back to analyze, compare means, and try any of these. All these are means difference tests. So when you're comparing, you can only see how how men and women are, or how males and females are. But if you really want to know where their means differences were statistically significant or not, you need to try any of this. But to begin with, I'll try only one sample t-test. Now before I do that, I want you to pay attention to the purpose of one sample t-tests. In one sample t-test, in your previous trimesters, you would have studied about what is called t-test and z-test. Both are one and the same actually. When z-test is conducted when the population's standard deviation is known, which is a perfect test in one sense, whereas t-test is conducted when population standard deviation is unknown. So therefore, over t-test, z-test is more perfect. But however, in most of the cases, we might not know the standard deviation of the population. And that is the reason we go ahead with the t-test. This is the standard instruction or the condition by which you analyze or apply t-test. But here I'm going to demonstrate using one sample t-test. So what I'll do, I will take only one sampled t-test and select the age of the respondents. So age always in actuals, because when I'm calculating mean scores, they must be continuous or interval data. So I'm taking age and my test value is only one because there's only one variable I'm choosing. Now this is my confidence interval 95%, and then I would click OK to know how my data distribution is. So my overall sample mean age is 38.48 years with standard deviation of 9.38 years, and then the standard mean is 0.65. Now if I look through my t distribution, t test value for age is 57.63 at 207 degrees of freedom, and my total significance is 0.000, which means my null hypothesis stands rejected. My null hypothesis is the mean age of sample and population mu are equal. So mu and sample mean are equal, whereas my t distribution t value suggests that they are not equal. So therefore I will reject the null hypothesis. So when I want to calculate the one sample t test for age, this is the method I would follow. I hope you have understood. You can still try that. Not much used in the field, but I can still try more comparative mean analysis. So I can try now independent sample t-test. So here what I would do, I will choose again age, then I'll choose gender as a grouping variable. Now, how many groups are there in age? You know, t-test is applied only when there are two groups. When there are more than two groups, you have to select ANOVA or one-way analysis of variance. So Here in the grouping variable, which is called a gender, I need to define how many groups are there. So I'll click define group 1 and group 2. So group 1 is male, group 2 is female. So I'll click continue. Then what are the options? I'm confining at 95% confidence interval. So let's move on and then click OK. Now that's my output. So the average age of males is 37 and the females is 39 with standard deviation of 9 point. Now you can see here I'm trying to calculate the t-test for age based on equality of variance or equal variances assumed. So here this particular value I am choosing. So my t t value is minus 1.38, degrees of freedom is 206 because that's n minus 1, and two-tail significance is 0.17. So here my null hypothesis is males and females do not differ in their age. However, my t-value is also not statistically significant at 0.170. So which means men and women do not differ in their age groups. So my null hypothesis stands accepted. I hope this clarity is already there in your minds. When your null hypothesis is males and females do not vary or do not differ in their age, and then the t value also suggests that at 0.17 there is no statistically significant mean difference, and therefore your null hypothesis stands accepted. What we can do, we can still try few more for more understanding. So let's click independent t-test. I'll remove age. This time I will pick up monthly income. Sorry, it's annual income. I have to correct it once and for all. I think this is the better time I should correct it. It's not monthly income, it is annual income. And in the brackets, it's better to mention in rupees. Save it and then go to analyze, compare means independent sample t-test. Experience also I will collect, number of subordinates, number of promotions. Fine. So I have already defined the groups, they are in the memory. So I'll straight away analyze it. So now I can see here my means differences are for monthly income, males have 4 lakhs 15,000, females have 4 lakhs 6,000. For experience sake, males have 7, females have 8 years. Number of subordinates for males is 5, females is 5. Number of promotions for males and females is equal in 2. So now what here you can see for monthly income, annual income, I think I've corrected it. But still why? Let me try again. Analyze, compare means, independent t-test. Click OK. I think now it is corrected, appended. So I can see the annual income standard deviations are very high. So let's move on with my t values. Now for annual income, the t value is minus 1.06 for degrees of freedom 206 and the probability is 0.29. So therefore null hypothesis is accepted. Similarly, in experience, null hypothesis is accepted. Number of subordinates, null hypothesis accepted. Number of promotions, null hypothesis accepted. So you should be wondering why this software displays probability values like this or significance values, but two-tailed. Now, in the previous classes also, I would have definitely mentioned that in social sciences, we always assume that our two-tailed significance level should be 0.05 or less than that. But 0.05 is our fixed assumed level. So when the when the calculated value is more than the table value at 0.05, we reject the null hypothesis. But here you can see all these values are above 0.05. Therefore, we accept the null hypothesis. So this is one more table. You can also take it into your final thesis. So that's how we will do it. Now we will move on with more than two groups. Now, I will not come to paid sample t-test because paid sample t-test is not applicable in our data set because paid sample t-tests are conducted only when you have experimental designs. So when you collect data before experiment and after experiment, you will use paid sample t-test. So in the present data set, that method is not applicable or not suitable, so I'm not going to demonstrate that, but certainly I will do it in some other data set. Conveniently, I will pick up one data set based on experiments, and in that experimental data I would demonstrate this method. In the meantime, let's move on with one way analysis of variance. So here what I'll do, I'll again use the same continuous variables like age. I'll avoid number of children. I'll pick up income, experience, subordinates, and promotions. And here I'll take my independent variable or factor as occupation because it has more than two groups. So I'll enter that. Now selecting the statistics, and then I'll avoid for conveniently these statistical procedures. These are a little higher ender, but since you're in the beginning, you don't have to worry about them. Homogeneity of means, post hoc tests, contrast, we will not worry about them, but gradually the serious student might move into all of these for further understanding. But to begin with, we will simply use descriptive statistics and F test. So I'll click it. Let's say conveniently I'll also pick up this. Yeah, that's the way my data would look like. So now here you can see age according to occupation. So there are three groups. Sorry, here also two groups. So I don't demonstrate it. I'm sorry, I'll get back. So where do you find three groups? Okay, designation, I suppose. Yeah, in designation we have three groups. So we'll get back to designation. So age, sorry, compare means one way, remove this variable and choose designation. I'll remove homogenities, don't need that. Click OK. So now that's how my output is. So age of employees, age of supervisors, age of officers. I'm so clearly able to see that. Now you can see that all of their age is 38 years with slight changes in their standard deviations. Never mind. So annual income, experience is also, so all are visible. Now I will move on to the hypothesis testing, whether their means are varying across three groups. Now you can see age, the F value is 0.01 with degrees of freedom 2 comma 207 2 comma 205 I think, and then the significance value is 0.99. So again you can see here all the two-tailed significance values are above 0.05, which means I am accepting the null hypothesis. In other words, age, annual income, experience, number of subordinates, and number of promotions do not vary according to the designation. So that's how I conclude my test. Now I'll close this off. So I'm sure we are almost through with all of these in the means difference test except paid sample t-test, which I will demonstrate through some other data and not now. So with that, I'll conclude with the compare means. Now we will go back to descriptive statistics as I have suggested that we would conclude with cross types. So it's a very very important method because in this statistical procedure you would be most frequently using crosstabs in your internship project reports and also specialization project reports. So in the Cross tabs, what we will do, we will click it and then see how a dialog box looks like. So cross tabs dialog box, as usual, as I told you, in every dialog box, on the left side you would find all the list of variables, and on the right side you have processing. Now what we will do, remember in cross tabs, row is meant for independent variable, column is meant for dependent variable. That's a standard understanding, always you should remember. Row is meant for independent variable, column is meant for dependent variable. That's a universal standard. So let's assume that I'm taking gender into the row and then designation into the column. So which means my gender here is independent variable, annual income, sorry, designation is my dependent variable. Now, very important, very carefully you have to learn from here is, first of all, you have to click cells. These are all your observed frequencies and expected frequencies. So here you have to see what are all selected already. So you don't need anything column wise, so remove it. Count and row percentages and total percentage, that's what we need. Let me check, I'm not sure. And then we'll get back to it again. So if I compute rows 40, 30, 23, yeah, that's correct. So I think I have done the right one. So get back to again descriptive statistics, cross tabs. Now cells, we always remove columns because we don't need column wise percentages. We always need row wise percentages. So you don't have to worry about them. But universally, we always interpret crosstabs row wise, not column wise. That's the reason I'm asking you to remove columns. Now, column wise percentage is removed. I'll click continue. Now get to statistics. You need to choose what type of statistical test that you need in the crosstab. So there are many crosstab statistics are there. I can apply chi-square. I can apply phi coefficient, contingency coefficient, lambda. There are many non-parametric statistics. Gamma, kappa, eta, correlation for ordinals, correlation for nominal ordinal, you can use that, but here I'm only using chi-square. So contingency also we can do. I'll explain you what is the purpose of it. So when I click and then say OK, my output is done. So here is my output. My next assignment, that is fourth assignment, is going to be based on how to interpret this table, because 95% of students will be using cross tabulations in their project reports. So they have to learn how to interpret this table using standard international norms that I'm going to explain you in sixth step or the last unit of the syllabus. So that's called unit 5, are providing explanations. That is the title of the class. That's going to be our last class anyway. So remember, our fourth assignment is based on this table, how to interpret cross tabulations. So the team leaders have to interact with all your team members. Each team member has to be given one or two cross tabulations which I am going to distribute. I will make tables, I will send them to the teams, and the teams have to distribute it among themselves, interpret them, and in a day they have to submit. Only next day, there's only one day to submit. So I will mention all those deadlines. Don't worry. But in the meantime, if you learn how to interpret these tables, I think it is going to serve your internship or project purposes. So this is how we compute the cross tabulation. Now you can see that how do we interpret that. As I told you, row wise always we have to calculate the percentages, and our interpretations also would be row wise. For example, our null hypothesis is designation does not depend on gender, or gender and designation are not associated. So if I have a null hypothesis like this, you can see among males, a large number of them, that is 40%, right? A large number of them is employees, followed by a little over one third of them is supervisors, and nearly one fourth of them is officers. Whereas, next paragraph, among females, A little over one third of them is officers, another little over one third of them is employees. The remaining of them is supervisors. That's how I conclude. And and then interpretation of the chi-square value. The chi-square value is 4.33 for 2 degrees of freedom, and the two-tailed significance value is 0.11. So as I told you in one of the classes again repeatedly, our significance value should not cross beyond 0.05. So when it crosses beyond 0.05, we accept the null hypothesis, and if it is less than 0.05, we reject the null hypothesis. So here you could see it's 0.115, therefore it is more than 0.05, and therefore I accept the null hypothesis. In other words, designation does not depend on the gender. Now, another important statistic which we have clicked here in the previous options is contingency coefficient. Always for nominal variables we use this statistic. Nominal by nominal. Independent variable is also nominal, dependent variable is also nominal. Now, contingency coefficient will suggest you the strength of association, whereas chi-square only will tell you whether there is association or not between the variables, whereas contingency quotient will tell you the strength of association. This statistic is applicable only if the chi-square value is significant, which means when you're rejecting the null hypothesis, then only contingency coefficient value is applicable. However, for the sake of interpretation, I would simply interpret it in this way, that the strength of association between designation and gender is 0.14, which is very, very weak, only for the sake of interpretation, otherwise it is not applicable. But for example, if the chi-square value is statistically significant, then I would, then the based on the value here, I would either say the strength of this association between gender and designation is either moderate or strong. That's how we interpret cross tabulation. So what we will do, we'll try another cross tabulation. So let's go to descriptives, cross tabs. Here instead of designation, I'll pick up some other variable. Let's say conflict. So I'll take one of the work conflict items. Now click OK. So that's my conflict items. So you can see that how males agree with conflict items, disagree with conflict items. Similarly, how females agree and disagree with the conflict items. So it's the same way. We have to always interpret the row wise. Always interpret the row wise. You can have one paragraph of interpretation for first row, then second paragraph of interpretation for the second row, and the third paragraph interpretation for the chi-square value. That's how our conclusion is. So with that I conclude cross tabulations. So I'll pause here, and in the next video I'm going to show you how to move on with correlations. I hope we are fairly slow in learning this because we are doing it for the first time. In case if you have any problems, any doubts, revert to me. You can send through WhatsApp messages, you can send an email, or whichever the way, telephonically also, you can try that. So I once again wish you all the best. Keep practicing. That's the only clue, that's the only answer for any kind of problems. Keep practicing because practicing only makes you perfect. There's no other way. So that's it for now. So in the next video, I'm going to show you how to interpret or how to calculate correlation and also multiple regression. So with those two things, I think our next session would conclude. I think that should be enough for today. And tomorrow we'll come out with something very interesting, very new statistical test you never heard before, you never tried that also. It is called factor analysis, one of the toughest and one of the interesting statistical tests that I'm going to demonstrate in the next class. And then we still have many more. Dear students, dear students, welcome back to the fifth part of sessions on analysis of data. We had already seen 4 sessions on analysis of data. This is the fifth part, and we have one more part called the sixth part, and there we'll have an exclusive statistical test called factor analysis. Dear students, welcome back to the fifth part of sessions on analysis of data. We had already seen 4 sessions on analysis of data. This is the fifth part, and we have one more part called the sixth part, and there we'll have an exclusive statistical test called factor analysis. So for today, we will only see correlation and regression analysis. In the meantime, I wish to draw your attention to some of the aspects of inferential statistics here, namely their correlation analysis, regression analysis, and factor analysis. So as of now, we will see only correlation analysis and regression analysis. So let's start with correlation analysis. Now, when Carl Pearson was the one who invented the concept of correlation analysis, this concept is based on canons of Mill, particularly the third canon of Mill, that is the method of concomitant variation. So if John Stuart Mill had not invented the canons of Mill, probably Carl Pearson wouldn't have got an inspiration to invent correlation coefficient formula. So I would credit the invention of correlation coefficient to the concept of method of concomitant variation of John Stuart Mill. Now there are various types of correlations. You would understand that in correlation you would always have one independent variable, another dependent variable, and all the variables have to be continuous. That is the first condition. All the variables have to be continuous in data, in nature, or namely they are called interval or ratio scales. But sometimes what happens, you might be constrained to apply relationship test on two ordinal data. Therefore, type of correlation changes. Similarly, the nature of relationship when you're trying to explore. The nature of relationship sometimes also depends on the kind of distribution that you have. If it's normal distribution, you can simply go ahead with Pearson's correlation. But if it is uh, not normal distribution, you may have to make some decisions. Not only that, sometimes you may have a set of independent variables and a set of dependent variables, but you cannot have multiple correlations, or you cannot have separate sets of correlation coefficients for the set. In which case, what you have to do, you have to establish simultaneously the relationship between set, independent set, as well as dependent set. In those conditions, you'll have various types of correlations. However, in this demonstration, I'm going to show only Pearson's correlation. I'm not going to show the other types, namely partial correlation, in which you'll have three variables interacting. Then you're familiar with rank correlation. There are two types of rank correlation: Kendall's rank correlation, Spearman's rank correlation, and then next one is point biserial correlation. You'll have the levels of measurement different in this. And then next one is called curvilinear correlation, which is a very peculiar relationship between two variables. In curvilinear relationship, the relationship between one variable is and the other variable is changing over the time. In the sense, up to some point it will be positive linear, and after some time it will be negative linear. So when the relationship is changing from positive to the negative, this is called curvilinear relationship. So curvilinear correlation is another method, and then finally canonical correlation, which is a very peculiar correlation. In this, you would see simultaneously the relationship between a set of independent variables and a set of dependent variables. So this is only for those who are interested in learning more about types of correlations, because in the future you might come across testing the relationships of these sorts. But as of now, I'm going to show you relationship between two variables, namely independent and dependent. When we move on to the regression analysis, we will see a set of independent variables but one dependent variable. That's the limitation of regression analysis. You cannot have more than one dependent variable. However, in this nature, in this universe, you will find more dependent variables in relation to more independent variables. So therefore, regression analysis has one major limitation. It can always test the relationship between a set of what you call independent variables and only one dependent variable. But when you have a set of independent variables and a set of dependent variables, you cannot run regression analysis. In which case, you have to go ahead with canonical correlation. That's the peculiarity. Where regression analysis has a limitation, canonical correlation comes to its rescue. Very rarely used anyway. So, how do we interpret the relationships between two variables? We had already seen that in one of the previous classes that when the relationship is 0.00, we assume that it is not. There is no relationship between the variables. But if it is starting somewhere from 0.199, we say it's a very, very negligible relationship. When the coefficient is 0.20 to 0.39, we say low relationship. Zero point 0.4 to 0.59 is moderate relationship. Zero point 0.6 to 0.79 is high. And zero point 0.8 to 1 is called very high. In fact, 1 is perfect relationship. So these are the rules of interpretation of correlation coefficients. Now in regression analysis, we know already you had studied in the trimesters previously that there are two types of regression analysis, namely simple regression and multiple regression. In simple regression, you would take one independent variable and one dependent variable, whereas in multiple regression analysis, you would find more than one independent variable but one dependent variable. That's the limitation of regression analysis, particularly the multiple. So that's all about the overview. I'll stop here for a while. So that's the overview of correlation and regression analysis. But this particular fact analysis is something which we will see in the next class recording, not today. So I'll discontinue with this PowerPoint slide. Let's move on with our software. Now, I default kept it open and then I'll open up our own file, namely conflicts and satisfaction. Now here I would like to today spend some time on creating index, particularly of work conflicts, family conflicts and interrole conflict, followed by work satisfaction, family satisfaction and life satisfaction. So these are the three variables have to be created. Actually, in our data set, we find only ordinal measurements, or in other words, the scale items and the responses collected for those scale items. So there were actually 24 items for conflicts and then the remaining items for satisfactions. So these 24 items divided by three types of conflicts, which means each conflict has about 8 items. So what we are supposed to do now, compute an index for each of these 8 items separately for work conflict, family conflict and interrole conflict. So what I'll do very quickly, I'll show only two. One, instead of showing the computation of all the variables, what I would do, sorry, I will demonstrate only work conflict and work satisfaction, only two of them. So what I'll do here, I'll go to a menu called transform. We never used it before except for record. This time I'm going to use compute. So here what I'll do, I'll click compute and then I will also go back to my particularly the code book. That's very important because without code book it's very difficult to trace the variable list. So that's it. I'll close this. Let me go back to the code book and then you can see here what conflict items are V12 to V19. So straight away here what I'll do, target variable is called work conflict index WCI, I will call it. I can give a label also here to it, work conflict index. create an index. And how do we create an index? We know our variables are here. So this is our first variable v12, then plus v13 plus v14 plus v15 15 plus, I have to move the list, v16 plus v17 plus v18 plus v19. So that's my work conflict items. So I'm adding all the 8 items pertaining to work conflict index and then creating a consolidated score, or it is also called composite score or simply an index score. So that's it. Let me check through my code book for its creation. See, here it is created already. So WCI work conflict. Work conflict index is created. Now I don't have to give labels because it is a continuous variable now. See, you can see automatically it is changed. It's a interval scale now. When I join all ordinal items together corresponding to one particular concept, all those ordinal scales added together becomes interval scale. This is the trick. Because in ordinal scale you are constrained, you cannot apply higher statistics. When you convert them into interval scale and ratio scales, you can apply any type of statistics. So that's how we do it. And then let's get back to our code book again. Now, work satisfaction. Let me complete with the other also, 20 to 27. So 28 to 35. I think we should complete them. So I'll go back, transform, compute. I'll remove this by pressing reset. Those old ones will disappear. Now family conflicts with starts with V20 and ends with V27. So I'll go back. Family conflict index. Type the label called family conflicts index. Continue. And here V20, you can even type like this, V21, V22 to save time, V23, V24, V25, because I come from a days where we are using only DOS operating system. So I'm comfortable with keyboard rather than using a mouse. But you can always try mouse because you're comfortable using mouse. I'm not. So V27. Sorry, there's some error here. So even if you make any mistake here by forgetting the mathematical operations or the variable number, it doesn't accept. So now I hope it is through. So V20, 21, 22, 23, 24, 25, 26, 27. How many are there actually for? Yeah, 27. So that's it. I'm clicking OK. Now my family conflict scale is also, index is also created. Very quickly I'll compute the other one, interval conflict 28 to 35. So in 28 to 35, so it's called interval conflict index. So I'll type the label interval conflict index. Continue. Now how many are those items? 28 to 35. So V28, V29, V30, V31, V32, V33, V34, V35. That's it. Interval conflict is done. So I'll again check any errors are there here. I hope it's not. No error. So I'll click OK. I think it's created. Very quickly I'll finish off with satisfaction items also. So 36 to 41, 42 to 46, 47 to 50. So let me start with work satisfaction 36 to 41. Transform, compute, reset, work satisfaction index. And I give a label work satisfaction index. Click continue. and then type out V36 to 41. Sorry, V36, V37, V38, V39, V40, V41. That's it. So I'll click OK. Then I'll go with family satisfaction index, FSI, then the label family satisfaction index. Continue. Then check through how many items are there. 42 to 46. So V42 plus V46, V43, V44, V45, V46. That's it. So I click OK. Done. Now the last index, using compute command, reset life satisfaction index, LSI. So life satisfaction index. Continue. Then check through how many are there. V47 to V50. So V47 to V, sorry, there's something mistake. V47, V50. So V48, V49. That's it. V50. So it's done. So time to save the file. I've saved it. Now let's check through our data view window to know how the variables, how my files are saved, how those indices are created. So you can see here, these are the indices created, right? Family conflict, sorry, it starts with here, work conflict, family conflict, internal conflict, work satisfaction, family satisfaction, internal satisfaction. Now you can see the distribution, it is continuous. So that's how we create the index, and then afterwards it's time for us to check through our output. There's a lot of junk here. I'll close this output file without saving, and then I'll move on. So we'll start with correlation first, and then we'll slowly move to regression analysis. In correlation, I will only show you Carl Pearson's correlation, particularly the bivariate. So go to analyze. They can see here bivariate correlation. So click bivariate correlation, and then go to the bottom of your list. Then you can see work conflict, family conflict, internal conflict. You can choose all of them, or what you could do, choose only one at a time, because your hypothesis, work conflict and work satisfaction are inversely related. So I'm picking up two-tailed, and then see how conflict and satisfaction are related. They must be inversely related. So I'm typing it out. Now here you can see work conflict and work satisfaction are their correlation coefficient is 0.73. There's something wrong with this. I need to check up. Though the relationship is very strong, 0.73 is very strong, but there should be a minus symbol here, because conflict is a negative item, satisfaction is a positive item. There must be a minus symbol here. So when the minus symbol is not happening here, I must have goofed up with the coding. The coding of my ordinal scale items that strongly agree to strongly disagree. Strongly agree should get 5 points, strongly disagree should get 1 point. If I have swapped that scoring, my relationships will be positive. So if I convert that scoring, recode, then probably the minus symbol will appear. I need to cross check it. It's not time now to do that, but let me keep trying some more correlations. Analyze bivariate correlation, press reset, go to the bottom of the list, this time what I'll do, I'll pick up all of them. Work conflict, family conflict, entire set of 6 concepts. So this is how my intercorrelation matrix it is called. So I can always see simultaneously how work conflict is related to family conflict, internal conflict, work satisfaction, family satisfaction, life satisfaction. All are positively related. I can understand if work conflict is positively related to family conflict and internal conflict because all are negative concepts. So minus into minus should be plus. But work conflict should not yield positive relationship with work satisfaction, family satisfaction, life satisfaction. It could be because of the mistakes in the coding. Similarly, family conflict. So what you could do, how these 3 conflicts are related to 3 satisfactions. That's the actual purpose. So our null hypothesis is there is no relationship or there is no negative relationship between conflicts and satisfaction. So null hypothesis means no negative relationship, but here it's positive relationship. So we'll accept null hypothesis according to this understanding. So that's how we interpret uh, the correlation coefficients. And then since all work conflict items and work satisfaction items are significantly correlated, I can run regression analysis. What if these values are not significantly correlated? I cannot run regression analysis. That is the constraint. So correlation is a precondition for regression analysis. Without correlation, we cannot run regression analysis. Remember this forever. If your correlation coefficients are statistically insignificant at 0.05 level of significance, you can also call it alpha, in which case you should not run regression analysis. You have to stop your study with correlation. But interestingly, since all our dependent variables are very strongly correlated with independent variables, we can run regression analysis. So what I'll do, I'll try one simple regression, one multiple regression. Only 2 things I will demonstrate. So what I'll do, I'll close this file, go back to my analyze command. So I can see here regression. So I'm not going to use binary because here it is when you are using ordinal and interval you will run, or dichotomous and interval you will run binary logistic, but since our variables are all continuous we will run only linear regression analysis. So let's click it. So you have a dialog box like this. So here what we'll do, we'll try first simple regression. So go to work conflict into independent and work satisfaction into dependent, move them. Then what all do you need? Beta coefficients you need, multiple R you need, analysis of variance we need. That's it. Yes, we need these. So by default I'll retain them and then click OK to see the output. That's it. So you can see my multiple R between work conflict and work satisfaction is 0.73. Now R square is 0.53, or R square refers to coefficient of determination 0.53. Now my ANOVA suggests that the F value is 238 and the total significance is 0.000. Similarly, if you look through the standardized coefficients, work satisfaction and work conflict has 0.73 beta coefficient and t value suggests that 0.15.45 at 0.000 level of significance. The effects beta coefficients have are statistically significant. That's why basically we interpret it. So we'll again come back how to interpret regression analysis. We'll start with first reverse order. We have to first present this table called coefficients. In the coefficients what we would show, standardized coefficients only we have to interpret, not sometimes they also interpret unstandardized coefficients. Unstandardized means there is an error in this value. So you can see here it is 0.99 unstandardized. whereas in standardized it is 0.73. Unstandardized means there are inherent errors in this value. So with errors, I will not accept it. So after the errors, that is called standardized coefficient, my value is 0.73. So I'll interpret 0.73, t value 15.45, and then significance, level of significance at 0.000. So I'll first present this table in my research report, so, and then interpret it. Work satisfaction index yielded a beta coefficient of 0.73, which is statistically significant for the given t value of 15.45 at 0.000 level of significance, which indicates that if work conflict improves by 1 unit, satisfaction increases by zero point 0.7 units. That's the way I would interpret. And then get back to R square. Here, what we would do, R square is called coefficient of determination. And then adjusted R square is again. The difference is in R square, you have some inherent errors. Whereas in adjusted R square, the errors are eliminated. So you can make a judgment between these two values. Either you want to retain this value or that value for interpreting. So I will suggest adjusted R square. So what does it mean? Coefficient determination of 0.53 suggests that work conflicts predict 53% of change in work satisfaction. So 53% is a very big contribution. So it's a positive result in this study. So work conflicts predict 53% of change in work satisfaction, and that is statistically significant. So that's the way we interpret the F value. So F value will suggest that R square is statistically significant. So that's how we have to present R square along with F value and significance, of course degrees of freedom also. So when we move to the last unit of the syllabus, I'm going to show you how to format all these tables and then how to interpret them and start writing the report. So that's there for us until now. So now in the next class, I'm going to show you what is called factor analysis. With that, we will finish off with unit 4 of the syllabus and then step 6 of the syllabus of our research process. So that's all. If you have any doubts, you can always revert to me. You can send emails, you can correspond with me on WhatsApp messages, you can send SMS, whatnot. Whichever the way you want to interact with me, you can interact with me, because we are almost getting through with the syllabus, and then we are also working out how to conduct midterm and end term exams. So get ready, because it's very soon we are coming out with some methodology in the institution. So we are discussing amongst all the heads of the department, and we will inform you in advance. In the meantime, don't waste your time. This is a wonderful opportunity to learn these processes being at home, and then technology is a God sent uh, gift to your generation. Use it thoroughly. In fact, I am also learning to use it, because for the first time I'm trying all these methods. I have learned phenomenally in this lockdown, particularly how to record, how to upload, and then it's really exciting. And then for an old guy like me, it's so exciting. I'm sure as a young people, you would be definitely enjoying all these technologies. So I wish you all the best, learn better, and then present things better to the audience. So once again, all the best.